Hey, we're taking a look at lesson 1.9. Now, you might remember from last class some things you might have forgotten since we covered 1.8 some things. So either way, this lesson is going to complete what we did last lesson on 1.8. 1.9 is a follow-up lesson. This time, what's going to be different is we're going to do a little algebra to get to the point. But other than that, our focus is the same. We're going to try to simplify rational functions. We're going to graph and describe key features. All that's the same. Here's what's different today. Today, we're going to do the extra step of factoring, which you've learned how to factor already. But we're just going to incorporate it into a rational function. As a reminder, a rational function is anything that's in this form right here. On this slide, this is your keys features cheat sheet. If you want to look over the cheat sheet, it's there. This is to help you solve. Today, I'm going to walk through this a whole bunch of times. If you notice, there are 6 key features here. 1, 2, 3, 4, 5, 6. It's the bold. Those are the cheat sheets, or the key features. This is the cheat sheet showing you how to do the 6 key features. Today, all through the packet, I have typoed, and I said to find the 5 key features. There are 6 here, and we're going to find the 6 as we go through today. By the end of today, hopefully, you will have down pat exactly how to find each of these key features. Okay, with that, let's look at example 1a. It says again, find the 5, change that to a 6. We're going to find our 6 key features for this rational function, then sketch its graph. Okay, so first, what I want you to do is we're going to factor this equation. And I'm going to ask you, if you remember, what's the best way to factor something that's 3 terms like this? X method. You first need to check for GCF though. Is there anything in common between x squared minus 2x and minus 15? Nope, they don't all share an x and no number. That's a 1, so nothing goes into it. So for X method, write A, B, and C, if you remember. Draw yourself an X. Put A times C up at the top, B at the bottom. Whoops, B at the bottom. Okay, what we do here is first, if you have an A that's just blank x squared, how many x squares do you have? 1. We're going to treat A as just being the coefficient 1, not x squared, just 1. What is 1 times negative 15? That goes at the top of your x. Now the B value is negative 2. That goes at the bottom of your x. Now as a reminder before we continue on, the goal here is we're going to come up with 2 numbers that go in the sides of this x. I'm going to call them m and n. The goal for m and n is that m times n needs to equal the a times c value. Let me say it another way. These 2 numbers need to multiply to be this value that's a times c. And then these 2 values need to combine, or you could say add, to be the b value down below. That's the goal. So I'm going to write in all the possibilities. What are the possibilities that can multiply to be 15? I think it's a lot easier to do multiplicatives first, and then figure out positives and negatives and such second. I hear 5 and 3. 5 and 3 is an option. 5 and 3 and 1 and 15. Now those are the only 2 values, the only 2 sets of values that I know of that multiply, that are integers, multiplied to be 15. Should keep that up, please. Okay, now after you find your set that can multiply to be a 15, now the truth is I should be writing pluses and minuses on all these. They could be positives, negatives, any combination. But I'm just going to figure out which one's and then we'll just put the negatives as we need them. Okay, which one can combine to give us a negative 2? That's right. Now, if in case you're struggling, how could they combine? There's 2 options for each numbers. These could add to be an 8, or they could subtract to be a 2. That's the only 2 options. They could combine to be an 8 or combine to be a 2. These could combine to be a 16 or combine to be a 14. We need it combined to be a 2. So the first 2 are out. I'm sorry, 1 and 15 are out. And to make it be a negative 2, which one needs to be negative 5, Sanaya? Negative 5. I agree with you. So if you remember what that means, I'm going to put here step 1, factor. What we're going to do first today is we're going to factor. What that means is we can now factor the numerator like this. So we can say this a term splits apart, and so it's going to have an x times another x. So instead of being 3 terms, terms mean adding and subtracting, it's going to become 2 factors that are multiplying. The x times x gives us our first term of x squared. These 2 side numbers provide the other 2 terms. And so the negative 2x will come when you multiply by negative 5 times x, and this x times the 3. When you combine those, you get the negative 2x, and then negative 5 times the 3 gives us the negative 15. That's how the math works. Now let's reload and try this again. Let's look at the denominator. Here I'm going to label it a, b, and c. So I'm going to draw another x method. And again, a times c in the top, b goes on the bottom. This time, a is blank, so I put a 1. What is 1 times 10? 10. And my b is negative 7. So again, don't worry about the negatives. They don't matter at all. What are the only options that multiply to be 10? What are the only sets? I hear 1 times 10, and I heard 5 times 2. By the way, if you're wondering, order does not matter. You can write in any order. Those are the only ones. Now, which ones could combine and give us a 7? It's 5 and 2. Okay, so once you know that, you can eliminate the other option. And now you ask yourself, okay, now let's figure out the negatives. How do I make something become a negative 7? 5 negative, a 2 negative, both negatives. What do you think? Both negatives. If they're both negatives, then it'll work. So again, I split the a term, so it'll be x minus 5 and x minus 2. Now that's our first step. And absolutely, you're getting into the key features. So after we do the first step, we're going to secondly find our key features. And that comes from simplifying most of these, I should say. 4 out of 6 come from simplifying the equation, okay? So to find my key features, let's come up here and look at how I could simplify this equation. Do you see anything that could cancel? Okay, those become wholes. So cross a line through it, and I'm going to put whole, not holes, I should just say whole. And the value would be x equals what? If it says x minus 5, the factors that are canceling. 5. Okay, now that's on the cheat sheet. You can go back and it'll tell you the wholes are factors of x that cancel. That's what the cheat sheet tells you. Okay. Now this right here, does the x plus 3 cancel? Things in the numerator, if they do not cancel, become a 0. This is a 0. We will have a 0 at x equals negative 3. Now, if it remains in the denominator, like this one, it's not a 0. This becomes a vertical asymptote. For now, I'm going to put VA because I don't have much space. I'll write vertical asymptote over here. This will be a vertical asymptote at x equals what value? Positive 2. Now, that right there looks like 3 pieces of information. It's actually going to generate us 4 pieces of information now. So, the first of our 6 key features, first, domain. So the first is our domain. Domain is always going to be any value of x, any true value of x that ever was in the denominator. So you see how I have a vertical asymptote at x equals 2 right here? Well, this one, even before it simplified, became a value that x cannot be, because you're not allowed to divide by 0. I don't think I said that. You're not allowed to divide by 0. Remember that rule from earlier this school year? You're not allowed to divide by 0. So any value of x that originated in the denominator you cannot equal it. So this time I cannot equal 2 values. I cannot equal positive 2 and I cannot equal 5 because it was shared. It was in the denominator as well. Make sense? So here's how you write the domain. You're going to say x cannot equal the value of 2 and it cannot equal 5. So you're going to say x cannot be 2. It cannot be 5. However, x can be everything else. So I'm going to do semicolon XER. That means though x cannot be positive 2 and x cannot be positive 5, it can be every other single number. You making sense to you? That's from the denominator. Domain from the denominator. Domains from the denominator. Domain is from the denominator. You got it. Okay, wholes come second. Wholes. Well, in this case, it's just a whole. We only have 1. We know the x value. A whole is going to be a point. So right now it's like this 5 comma, and I don't know the y value. So I'm gonna put a question mark just for a second. Did someone ask a question? The whole, I know it's at x value of 5. I don't know the y value. What you have to do here is you have to plug in the value of 5 into the simplified equation. So I'm gonna say y equals, not f of x, because I've simplified the problem. I'm gonna say y equals, and I'm gonna plug 5 into what's left over. So you see what's left over is this x plus 3 in the top. So I'm going to say 5 plus 3. Okay, pause. Where did I get 5 from? The whole's value. So I'm plugging in the whole. Okay, I'm plugging in this 5 into there, and I plug it into down here as well in the denominator. 5 minus 2. That can simplify. What is 5 plus 3? 8, and 5 minus 2? Does that simplify? That's going to be our whole value right there. I don't have much space, so I'm going to try to sneak it in. 8/3. There we go. So let's go ahead and put that on the graph. So the whole is going to be right 5, 1, 2, 3, 4, 5, and then up positive 8/3. That's almost the number 3. So 1, 2, 8/3 is going to be just underneath the value 3. Put a hole there. That value right there is 5, 8/3. That's what that hole is. Everybody tracking? Okay, now that's the hardest one. The rest are a lot easier. The vertical asymptote. What did we say our vertical asymptote is? It's x equals 2. You need to make sure you include x equals 2 every time. So we're going to say that is x equals 2. Here's what that will look like. That'll look like a dashed line, and its vertical means, show me with your arm. Does vertical mean this way or this way? Which way is vertical? Up and down. When you do a dashed line up and down at 2. So right there, whoops, why is it not doing it? Let me try this board. Let's see if this works. Up and down like this, x equals 2. That's a vertical line. It throws off some students that it's called x equals 2 when it's going up and down. The reason it's x equals is because the only thing that's in common at any point on this line is that the x is 2. The y is changing because it's going up and down. The y's change, but the x is always a value of 2. That's why they call it x equals 2. Okay, fourth value that we already found is the 0. Where do we have a 0? X equals -3. Make sure you put x equals. That's essential. So go to -3. 1, 2, 3. Put a point. That's our 0 there. Now finally, last two. Our next point has to do with the end behavior. So this is going off the exponents. You look at the original exponents and you ask yourself, there's 3 options here. And again, this is all in the cheat sheet. You ask yourself, are my exponents the same? Are the exponents bigger on the bottom or are the exponents bigger on the top? When you compare your degrees, are the exponents, the degrees, the highest exponent, are the exponents the same? Are they bigger on the bottom or are they bigger on the top? What's the case here? The same. If it's the same, it's a horizontal asymptote. The exponents are the same. So what I'm going to do is I'm going to put the rule in parentheses here. The rule is eats DC. If you look back, what that means is if the exponents are the same, the equation is going to be y equals, and then you divide your coefficients. So what are the coefficients? What are the numbers in front of my powers here? 1 and 1. So it's going to be y equals 1 divided by 1. What is 1 divided by 1? 1. This will be a horizontal line. Horizontal asymptote, horizontal line. Which way does horizontal go? Show me with your arm. Good. It should be kind of flat. Go to horizontal at 1. That's the equation y equals 1. Again, the reason why it's y equals is that's the only value that does not change. The y is always a value of 1. It's always 1 up. Our last key feature. It's this leading term divided by this leading term. Leading coefficient divided by leading coefficient. 1 divided by 1. That's how we got it. Finally, the last thing is our y-intercept. How you get a y-intercept is you plug in 0 into the equation. So when I plug in 0 to the equation, you can look at the original or the simplified. It doesn't really matter. I'm just going to go with the original. When you plug in a 0, anything with an x would disappear because what is 0 squared? 0. What's -2 times 0? 0. Anything with an x cancels out. And so I just go with the original. You leave, all it's going to be are the c term divided by the c term. This is going to be -15 divided by 10. Can that reduce -15 divided by 10? Yes, it can. What is the same thing as -15 divided by, what number goes into both -15 and 10? 5. This becomes -3 divided by 2. That's -1.5. Go to your graph. Go down 1.5, put a point. There it is. Now, if you connect your dots, you'll have your graph. Now, there's those 2 points. This one would reflect across. Most of these graphs, they'll either reflect across diagonally across the asymptotes, or they'll go across horizontally. This one, because I had the points diagonally, I need to connect it this way. I'm going to pause here and show you the graph in the calculator. All right, now as I look at this and I show you the equation, you can see I do have a y-intercept at -1.5 or -3/2. We have a 0 at -3. Notice the graph. Asymptote, I don't know if I said this earlier. I'll say it out loud now. What an asymptote is, it's an area where the graph is approaching. Do you remember the word approaching? It means it's going there, but it never actually gets there. It never actually gets there, but it's approaching it as it goes off the graph. You see how this graph is approaching it? That means we did everything correctly. I have it all on there. It looks good. One other thing I'm going to show you is we said there was 2 spots that our domain did not exist. We said the graph was all reals except for 2 points. What were the 2 values of x that we said the graph does not exist? 2 and 5. Watch what happens when I press Control T here. When I press Control T, which shows me my table, what does it say at 2 and what does it say at 5? Undefined. That's the 2 places in the domain. If you ever need to check domain, go to your table, because our calculator does not show us a hole. The calculator will show you an asymptote. I added in the red line, but you can see that it's breaking at +2, but it won't show you a hole at 5. So, but if you go to table, it'll tell you where the domain is broken. You can figure out your hole that way. Does that make sense? And it certainly doesn't tell you the y value at the hole, but there it is. So if you don't have any questions on that, I will move on. Any questions on 1A? Okay, I'm going to roll through this 3 times before I give you a DOL. Okay, so you just saw me do everything once. The second time, I'm going to kind of guide you through it again. And on the 3rd one, I want you to guide me through it. So I'm going to do one more where I guide you through it, because it was 6 pieces of information. So first up, let's change that typo. Change it to find the 6 key features. Now, to start off, this is the way you're going to see an equation, but you cannot do any work with that. What's wrong with this equation? Or why can I not work with it yet? It's not factored. We need to factor it first. Okay, the numerator this time, I need to do something before I X method. There is something in common with every value. What do they all have in common? A 3. This does a 60 doesn't have an x. That's a good thought, but 60 doesn't have an x. But they all can have a factor of 3. So I'm going to do a GCF, a greatest common factor. If I divide out a 3 from each term, I'm left with x squared minus 27 divided by 3. What's 27 divided by 3? 9. So x squared minus 9x plus, and now what's 60 divided by 3? Not 30. 6 divided by 3 would be 2. So 60 divided by 3 is 20. Okay, there it is. So this is our A, this is our B, this is our C. We'll do an X method right here. Factors of A times C that add up to B. Again, A is blank, so I'll put in 1. 1 times 20 is 20, and B is -9. So we're looking for factors of 20. Just start calling them out. What are values that can multiply to be 20? I can think of at least 3. 4 times 5, and that's going to be our winners. Order doesn't matter, so you don't have to say 5 times 4. 4 times 5 counts for that one. 2 times 10 is another, and I can think of one more. 1 and 20. 1 and 20. Those are them. Now, which one can somehow combine to give you a 9? This could give you a 9 or a 1. This could give you a 12 or an 8. This could give us a 21 or a 19. So the value is going to be 4 and 5. So I'm going to cross out these that are wrong. And now how do I make it be a -9? Both negatives. Very good. So here I'm going to do step 1, factor. Actually, I need to go slightly lower just so I can have room to write. It's going to be g of x this time. And we just discovered, don't forget the GCF. 3 goes out front. But then we do x minus 4 as our second factor. Technically 3 is a factor. And then we place x minus 5 as our third and final factor. So we have 3 factors, 2 involving an x, but 3 factors total. Good with that? Now let's do the denominator. A, B, C. Do I have any GCFs this time? Nope, so I can go straight to X method. Factors of, this would become -8. That combined to be a 2. What are my options again? 4 and 2 is an option. And 1 and 8 is an option. Those are my only options. Which one can give me a 2? Well, this could give me a 6 or a 2. This could give me a 9 or a 7. I need a -2, so it's got to be 4 and 2. How do I make it a -2? -4. So this factors become x minus 4 times x plus 2. So that's our first step. Now, the second step after you factor is now you can find your key features. I'm going to write them out neatly, but most of them you can identify just by using that equations. First, what do you see mathematically we could do with this equation? I typoed, I wrote something wrong. Do y'all see what I wrote wrong? This -5 needs to be a -4, -4, -5. There we go. Okay. What do y'all see that happens on this one? You cancel. If they cancel, what do we call that? A hole. And a hole you can put on the top or the bottom. Doesn't really matter. But it's x equals 4. We're going to have a hole. Okay. I'm going to go out of order. I'm going to come back to 3. What do you call an x minus 5? It's in the numerator and it's left all alone. Nothing happens to it. Larry, you remember? You got it. It's a 0 if it doesn't cancel. X equals 5. What if it's a factor of x that remains in the denominator? That's a vertical asymptote. X equals -2. Okay, this 3, does it have an x with it? Is there an x with a 3? This is nothing. I'm going to do an NA. It will not be a key feature at all. That's nothing. If it's just a number, it's nothing at all. For key features. All it will do is it'll change, and it's a vertical stretch. It'll just change how quickly the graph got, all right, like it'll change like the C curves, like how narrow or wide they are. That's all it does. Okay, so our key features. The first one we did last time was domain. The first of the 6 was domain. Do you remember where you get your domain? Anything in the denominator that does not cancel. I'm sorry. Anything in the denominator, whether it canceled or not. That's what I meant to say. Anything in the denominator, whether it canceled or not, you include it. What do I have in the denominator? So 4 and -2. I'm going to go in numerical order. I'm going to write -2 first, followed by 4. Order does not matter, but that's them. We cannot equal those values. That's where we'd be dividing by 0. So put x does not equal -2 or 4. But do you know what x does equal? Everything else. All reals except for -2 and 4. That's our domain. All right, next key feature. The order I'm going to do it is the hole. What do we know about our hole so far? The x is +4. Do we know the y value? So for the moment, I'll put a question mark. And then we'll solve for that. How do I get the y value of the hole? You plug the hole into the remaining equations. So I'm going to go y equals, instead of g of x, because I'm going to take that away, I have 3 times, my whole value is 4. So it should be 4 minus 5 over 4 plus 2. Close. That's a -1. What's 3 times -1? So it becomes -3 divided by 6. That can reduce. What is -3 divided by 6? -1 over 2. The 6 is larger, so the 2 needs to go to the denominator. So that is our y value. We just solved for our y value, so I'm gonna plug that in right there, -1/2. So go to the right 4 units, 1, 2, 3, 4, and go down about half and do an open circle for the whole. That is that value there at 4, -1/2. That's what that is. Now that's 2 key features. The next key feature I'm gonna write is vertical asymptotes. I'm just gonna do VA from here on out. Did we have any vertical asymptotes? Where at? X equals -2. Make sure you put x equals. If you don't put x equals, you will not get credit when it comes time to get college credit. You will not be given college credit for that. If you don't put x equals. All right, so there it is. A vertical asymptote. I forgot to ask you, I should have. Vertical asymptote. Show me with your arm. What is the vertical? Which direction is vertical? Up and down. That's why I did it up and down. There you go. Okay, our fourth key feature. Yes. Sorry. Good job, Giovanni. Good shot. Good job catching me. I did put it at +2. It's -2. There we go. -2. Got it. I wish your packets worked that way where you could do that, but sorry. Maybe when your kids are alive and in class, maybe their paper will be smart like that. You can just slide it over, but not yet. Hadn't figured out that technology. Let's go on to the next. What's our next key feature? Zeros. Now these 4 we all get from the factored form. Did we have a 0 on this one? X equals 5. And good answer there, Daisy, saying x equals. So go to 5. 1, 2, 3, 4, 5. Put that point there. We need that 0 at 5. And then we will, the last 2, I think it's easier just to go to the original equation. So ask yourself, this is for the end behavior. For the end behavior, there's 3 options of rules. It's either the exponents are the same, your exponents are bigger on the bottom, or they're bigger on the top. What's the case this time? Nope. Exponents are the same. If the exponents are the same, or if it's bigger on the bottom, it's a horizontal asymptote. In this case, since the exponents are the same, I want to put this in parentheses again. Since the exponents are the same, you divide your coefficients. The equation is going to be y equals, and the reason I say go to this, it's easier to see. It's 3 divided by 1. It's going to be at 3. So let's go to our graph. This is a horizontal line at 3. The graph will approach that. Last point, the y-intercept. And again, I think this is the easiest if you just plug into the original. I'm gonna put g of 0. Everything with an x will cancel out, it will disappear. So basically is 60 divided by -8. I know 4 goes into both of those numbers. Do you know how many times 4 goes into 60? 15. Do you know how many times 4 goes into -8? -2. So it's 15 divided by -2, which is -7.5. So the question is, how am I getting the y-intercept? What you do is you plug in 0, and so anything that has an x gets replaced by a value of 0. That means when you're multiplying, since that's what's happening here, this cancels, this cancels, this cancels, this cancels. All that's left is this 60 divided by -8. That's what I wrote here. 60 divided by -8, 4 goes into both those numbers, and it goes in 15 times into 60 and 2 times into 8. And it's -8, so -2. Does that make sense? That right there is the decimal -7.5. So if you go to your graph, go down 7.5, that's right here. That last box is a -8, so that's -7.5. That's a value of 0, -15 divided by 2. That's what that is right there. Now we can connect our graph. Now every graph has to approach an asymptote. So these points will connect. And then it'll approach the asymptote from there. So it's going to look something like this. And here's what I know. Graphs are either going to they're gonna be always to the left on your asymptotes. They're either gonna go straight to the left or diagonal. This one has to be diagonal. The reason I know is because do we have another x-intercept over here? Since I don't have another x-intercept, another 0, this one has to be diagonal, so my other piece is gonna be over here somewhere, like this, going the other way. So I'm just gonna add that in. I know it's over there just because I don't have another 0. It has to be diagonal. It's either straight across, kind of like an even function, or diagonal like an odd function. So this one has to be there. I'm gonna pause and I'll show you the actual graph now. Okay, so here's the graph, and I'm gonna zoom out just a tad, man. This is just a little bit too close. I'm gonna go for, how about 16 and -16? And then I'm gonna change these to -20 and +20. So you can see this a little bit better. Okay, so here's my graph. I don't know where to put that. That's just covering it up. I'll put it in this corner. No, I'll just put it up there. There's my equation. As you can see, does this graph approach on both ends? Does the end behavior, does it approach 3 on both sides? Does it approach that? Does it look like this end of the blue graph and this end are approaching this value of y = 3? Yeah, that's what it's approaching. Does it look like both ends of the C curves in the center here is approaching x = -2? Does that look true? Yeah, do we have a y-intercept at -7.5? We do. And do we have a 0 at 5? We do. Now, there was 2 places on the domain where it did not exist. Do you remember what they were? Look at your packet. 4 and -2. So what does it say at 4? Undefined. What's it say at -2? Undefined. We did it correctly. That's your domain. You check your table. That's how you do that. All right, you have seen me do this now 3 times. Twice, I'm sorry, twice. The first 2, I've guided you through it. This next time, I want you to guide me through it. I'm about to give you a DOL. So I really want you to guide me through this time, the process of how to find these 6 key features. Again, typo here. 6 key features. Walk me through it.
They all say.
They do. They all say 5. We need a factor first. The numerator, do you see a GCF? No. Okay, great. Let's just go straight to X method then. X method's great anytime you have 3 terms or if you have a squared. 3 terms or fewer, or if you have the squared as your leading term, X method's great. This time, what's my A? Okay, so you tell me what goes to the top.
-21.
-21, what goes in the bottom? Okay. I hear 7 times 3. Do you want to write any more options or just say it's 7 and 3?
So
Y'all know it's 7 and 3. It's not 1 and 21. Okay, so it's 7 and 3. Okay, now what? -3. Great. So we factored the numerator. Great. Okay, does the denominator have a GCF?
Yes, sir.
It does. What's our GCF this time?
Is that, wait, actually, is 9x comma or 9x
The comma is like for the sentence.
x, just x?
X, we have a GCF. Now, I sometimes forget the GCF. I want to put it there so I don't forget. If you take out the X, what are we left with? We're left with x squared minus, we're dividing by 1 power of x, minus 6x plus 9. All right.
So you just take it out.
You just move it to the front. You don't take it out. It's going to look like this. I'll just go ahead and give you a sneak peek. Where our equation is going to look like this time. You following? The x is going to come out here, and then we'll have 2 other factors from the x method. All right. New A, new B, new C. What's my A? Oh, I hear 9. You're talking about A times C. Okay, let's put 9 there. -6 there.
3, 1 is negative.
So we're not doing 1 and 9. We're doing 3 and 3.
Negative. I mean negative.
I agree that it's going to be a 3 and a 3. Now we need to get it to be a -6. A negative and a negative. Okay, a negative and a negative, I like that. So when we plug these in, it becomes x minus 3 and another x minus 3. Okay, what can you do if you have it written twice in the denominator though?
X minus 3 times 4.
That's right, and I'm gonna rewrite it x minus 3 squared, and I'm gonna show you why. It'll help you not make a mistake here in a second. If you always write, if a factor occurs twice, if you put it as squared, it'll help you out. So now, as I start our key features, I'm just gonna say KF. You all okay with KF? Here's our key features. So we factored it. Now our key features first, domain. Oh, you know what I haven't even done? I haven't even listed. Okay, what about x plus 7? What is that gonna become?
Oh,
That's a 0. Good. X equals -7. What about the x minus 3? This is gonna cancel out. But it only cancels. Now, if it cancels and there's still more, it's not a whole. It becomes a vertical asymptote because it still remains as a vertical asymptote. So this is gonna become a vertical asymptote. The x minus 3, so what does x actually equal there? 3. So what we're not, it's not gonna be a whole. Not a whole. At x equals 3 since it is a vertical asymptote. And I'm just gonna do a VA there. It's not a whole at x equals 3 since it is a vertical asymptote. So there's not a whole. So I'm gonna go ahead and go to whole here. At whole, we're gonna do NA. It's not a whole this time, it's gonna be a vertical asymptote instead. Okay, I didn't ask yet. We haven't done this x. What is x if it's just an x by itself? It's not a 0, that would be in the numerator. If it's an x, it is going to be something. Then it's not 1. That would be x minus 1 as a factor. Wait, I just realized someone said 0. Were you talking about the word 0, or are you talking about the it equals the number 0?
equals.
It equals the number 0. That's what it is. It's a vertical asymptote. It just dawned on me what you were saying. It's a vertical asymptote where the x is equal to 0. I thought you meant vocabulary word 0.
No.
You just meant the math value. It is a 0 like that. So we have 2 vertical asymptotes. What are my 2 values? I'm going to go in order here. 0 followed by 3. Let's go ahead and add those to the graph. So go to 0. Draw your dashed line. And then pause the 3 dashed line. Again, it's vertical, which means up and down. That's not 3. That's 0. This one is 3. No, it's positive 3. Because the inside's all liars. Come on.
Did you say a whole was great? Or what?
A whole on the previous problem, it's going to be where mathematically a factor cancels. So like if it factor cancels out, then it becomes a whole. This problem, it's not a whole, even though we canceled the factor, because there was still one factor left over. So if it's still left over, it becomes a vertical asymptote in this, like this case. And that was the reason for this example, just to show you that. Okay, what about the domain? How do you get the domain? It's anything that was ever in the denominator, whether it got canceled or not, doesn't matter. So what is x never not going to ever equal? 0 and 3. That's when we go to the table here in a little bit, it'll say undefined. But x can be every other single number. All other reals will have a value on that table other than 0 and 3. Okay, picking up. We've done domain, whole, vertical asymptote. Now comes the 0. Where's our 0? X equals not 7, but -7. Go to your graph. 1, 2, 3, 4, 5, 6, 7. Put a dot. That's not, I'm writing that backwards. -7, comma 0. That's where that is. Now, for the last 2, I look at the original equation. The first one, the end behavior goes off the powers. when you compare the exponents, are the exponents the same? That's option one. Are they bigger on the bottom? That's option two. Or are the exponents bigger on the top? That's option three. What can you tell me about my exponents? Bigger on the bottom. If it's bigger on the bottom, or if the exponents are the same, it's a horizontal asymptote. So this one, I'm gonna put in parentheses, the rule we're following is bigger on bottom, which is Bobo. The reason they call it Bobo is bigger on bottom, it's gonna be y equals 0. We're gonna have y equals 0 as our asymptote. So come over to your graph. Horizontal means flat. Draw a flat line like this. And this time you're gonna see that if it's a horizontal asymptote, you can actually cross it sometimes, actually quite frequently with rationals. The rule is if your exponent is bigger on the denominator, bigger on bottom, it's always going to be 0. So if it's bigger, if the exponents are the same, that's where you divide the coefficient by the coefficient. If it's bigger on the bottom, it's 0. And we haven't seen if it's bigger on the top, but we'll see that in a moment. Okay, last key feature, the y-intercept. Do y'all remember how to find this? Anything you plug in a 0. You plug in 0 into the equation. So if I plug in 0, anything with an x cancels out, which gives me a problem here because I cancel out everything in the denominator. That means there's nothing left over, which is zeros all the way across. Are you allowed to divide by 0? H0 is undefined, so there is none. So what I'm going to write here is NA. Since h of 0 is undefined, and you're going to see that in a moment. And when I press table, that 0 will be undefined on the table. Now, there's not much for us to graph to go off of. So this is one where I would need to type it in. I'm going to pause here to type this in. Okay, so here's our third graph here. That's covering up that. Let me move that. So as you see our graph, this is how the pieces will look. Now, I want to point out something to you. This is the only 0 we have. But if you looked at the pieces, you see how this made a parabola here? A parabola comes from what power? An even power. That means that the outside pieces will be reflecting like an even function does. You know how the even functions over across the y-axis? Now with rationals, it doesn't necessarily mean across the y-axis, but it does mean on the outsides of its vertical asymptotes. Because this had 2 vertical asymptotes, we have 3 pieces. If the middle piece is a parabola, then these outside pieces are going to be even. Now, I could have told you that this was going to be a parabola, not an S-curve. That's the other option. It could be an S-curve. And the reason I could have told you that is that we had no 0 in between. You see how we had no 0 between these two? It couldn't have been an S-curve because that would have crossed. It had to be a parabola, which means these two had to reflect. So that's what this graph would look like, okay? Let me go ahead and do this here. Now we'll just add it in as quickly as possible to our graph. If you haven't already, start that graph. It does cross that horizontal asymptote, which is okay. You can do that. I missed, obviously. Yeah. So this one crossed over, but the value will still approach that asymptote, which means even though it crosses over, it still followed it this way. Since this had to be a parabola in between, since there was no other zeros, it had to be a parabola. And it looked like to me it was about down 4 units or so. That's what it looked like to me when I glanced at it. This has to reflect straight across. So this piece is going to be over here. Now, if you did not have a calculator, what you would have to do is just plug in an x value and plug in an x value that's bigger than 3 and see if you get a positive or negative number. And then you could have reflected that across. That's how you could have done that. And this one, same thing. You could plug in a value, but it looked like it was about at -4 to me. 1, 2, 3, 4. Yeah, approximately a little bit higher than, so something like that. That's how the graph should look. All right, you've seen me do this 3 times. The important thing is not can you graph without a calculator. I don't remember ever having, as a last year looking at AP curriculum, that you ever had to graph without a calculator. I don't remember you ever having to do that. What you do have to find are the key features. Do you think you can find these 6 key features? Let's find out. Without using the calculator, see if you can find those 6 key features. I forgot to do a Control-T here to show you the domain was what we said as well. The domain was it could not be 0 and 3. So let me add that in. I didn't do that, but now I want you to go to the next slide. And I want you to take a look at your DOL. All right, let's go on to example 2. You might be getting this down. What I'm going to do here is I'm going to each time try to mix it up so we're getting totally different answers each time around. The last few I kind of went in a pattern. I wanted to show you one new thing at a time, if you will. This time I'm just going to mix them all up, what key features exist and what don't exist. What's an NA, what's not an NA. So let's start with this, but I want you talking me through it a little bit more this time. What's our first step? Okay, I hear GCF. What I would actually be looking for is GCF. What does the F stand for? Factor. We're going to factor because then we might GCF and we might use X method. Tell me about the top. It's already factored. A factor is what turns everything into a linear value of X, just meaning X to the first. Since it's already there, I'm just going to put it in parentheses. That's all I'm going to do. X plus 1. I'm going to put it in parentheses just for the sake of possibly canceling out. Talk to me about the denominator. It is a perfect square, but let's say you don't recognize that or don't know what that means. Do I have a GCF there? No. Here's what I do. The leading term, if it's a power 2 or greater, you're going to call that A. Always A. What is my A value if it has a blank? 1. The last value, this does not have an X at all. That's a constant. What letter represents a constant? What am I missing? B. That means my B value is 0. My B is 0 here because B is not even there. What is 1 times -4? -4. Okay, what are the factors of 4? It's either 1 and 4 or 2 and 2. Which one adds up to 0? 2 and 2. How do I make it add up to 0? There we go. So I'll plug these in. This becomes X plus 2 and okay, we factored it. Everybody good so far? So we go on to step 2, which is the key features. Now we determine our key features. And I'm just going to say KF for key features. Can I cancel anything? So if nothing cancels, what do you call a factor of X left over in the numerator called? What will that always be? That's a 0. So we'll have a 0 at X equals, if it says X plus 1, what does X actually equal? -1. There you go. What about these two on the bottom? They don't cancel. So what are they both going to be? Those are both going to be vertical asymptotes. If they're left over in the bottom, they're both vertical asymptotes. So +2 becomes X plus 2 becomes X equaling -2. X minus 2 becomes X equaling +2. Where, any holes? No holes. Okay, so here we go. First, domain. Domain are any values of X that were ever on the denominator. Whether they cancel or not, does not matter. Any values of X are what we cannot equal, because you cannot divide by 0. So what can I not divide by this problem? -2 and +2. What could I divide by? Everything else. So semicolon X, weird looking ER. That means I can divide by any number except for -2 and 2. Now on my table, that's where I'm going to be undefined in a moment. Tell me about my holes. What did you say there? There are no holes. There is no hole. Okay, what about the vertical asymptote? -2 and 2. I'm going to go ahead and add those on my graph. Vertical means which direction? Show me with your arm. Straight up and down. Good. 2 and -2. Now this one's good. I've been messing up all day, but 2 and -2 ought to be easy because doesn't matter if I get it wrong or right. I'm on the right side. I mean, it's one or the other. Okay, that's -2. That's +2. This graph is going to have 3 pieces. Everybody with me so far? 3 pieces of graph. All right, there was one more on there. What did I not? Oh, zeros. This has 1 0. So I'll do it singular 0. Where's my 0? X equals -1. Now make sure you're putting in your variables as I am. At -1, we have a 0 right there. Now it's time for in behavior. Our fourth one's in behavior. Fifth, can't count. Fifth is in behavior. You look at the exponents. Are my exponents the degree specifically? Are the exponents the same? Is it bigger on the bottom or is it bigger on the top? Bigger on the bottom. If its exponents are the same or bigger on the bottom, it's a horizontal asymptote. So this is Bobo. I'll put that in parentheses. Actually, I'm gonna do black here. I'm gonna change color so you can see. Bobo stands for bigger on bottom, y equals 0. You got it. It's y equals 0. So this is horizontal. Which way is horizontal? Flat. There you go. That means the outside graphs are going to approach that line. Approach means they're going to go to it, but not actually necessarily get there, but go towards it. We have one last point. The y-intercept. Remember, you plug in 0 for this. So I'm going to write down, I'm going to go ahead and do this in black as well because I'm looking back at the original. If I plugged in 0, the x cancels out. I'm left with 1 over -4. And that does not simplify. It's just 1 over -4. So that's just down a bit. Just barely down like this. Okay, I can tell this graph is not a parabola because you see how it's crossing over this asymptote, the horizontal. That means it's going to come over here as well. So if it comes like this, then it must be an S. Now, what else does it mean if it's an S? If it's an S, the outside pieces are not going to be across from each other horizontally. They're going to be diagonals. They're going to be diagonals. Now, I'm going to type in the calculator just to make sure I get it right. I don't want to make you erase or anything like that. So let me type this in. What's the equation at the top? X plus 1. Is that right? X plus 1, and then denominator, it was x squared minus 4, if I remember right. Yeah. X squared minus 4. X squared minus 4. Okay, as I look at my graph, it looks like we did everything correct. This was an S-curve, which means these pieces are diagonal. So all I need to do is add that to my graph. These C-curves, the C-curves that approach these asymptotes go along like this. Now, if you did not have a calculator, you won't be asked to graph these as far as I know. But if you were, I could have told you straight up at the start, these will certainly be diagonal across each other because the middle piece is an S-curve. If the middle piece is an S-curve, the outside will be diagonal. So all that would have to happen is you'd plug in a number bigger than 2 to the equation. If you got a positive, you're up here. If you get a negative, you would then down here and go diagonal for the other piece.
So to be considered
If it was a U, they would be left and right of each other. So we had one of those earlier. Let me go back to it. This one, you see how it's a U? You see how these go left and right? If it's a U, they go left and right across. If it's an S curve, they go diagonal across like that. All right. So what were our two values in their domain? We said the graph would not equal. Look at our table. What does our table say? 2 and -2 were undefined there. So yep, we did it right. All right, I'm checking the clock. I want to do one more here. Then I'm going to give you a different problem. So I might skip 2C, but we'll do 2B. This one I think we can go through pretty quick, and this one has something unique we haven't seen yet. So let's do 2B here. All right. First off, what do we need to do to start this problem? We need a factor. Good. Do I have a GCF here? I do actually. A number. What number can go on all the way across? 2. So 2 goes in to 2x squared, x squared times. You take your 4x divided by 2, and we're left with 2x, and then you divide -30 by 2, and we get -15. There's our values. We're going to do an x method off the new simplified trinomial right there. Trinomial means 3 terms. All right. What do you put? What value goes up in the top? On -15. Very good. What goes in the bottom? 2. I can think of 1 and 15. I can think of 3 and 5. Which option can combine to be a 2? 3 and 5. And specifically, to be a +2, the 5 needs to be bigger than the 3. So it'll be a +5 and a -3. Okay, so now we can factor this. So step one is to factor. G of x can be rewritten as, don't forget your GCF of 2 out front. Then an x plus 5. That's ugly. Let me try that again. X plus 5 times x minus 3. Now we have 3 factors, but only 2 factors of x. And the denominator, I'm going to put x minus 2 in parentheses. All right, for our key features. Start simplifying, and you can find the first 4. You can find your domain. You can find any holes. You can find any vertical asymptotes. And you can find any zeros by simplifying in that equation. Can I simplify? No, I can't simplify. So what does that mean? What's the 2? Nothing. That's nothing. What's the 5, the x plus 5 and the x minus 3 going to become? Those are zeros. So we have zeros at x equals what 2 values? -5 and +3. Good. Okay, what is this value on the bottom? The denominator? That's a vertical asymptote. That is at x equals 2. So let's fill those in. Make sure you put the x equals. What about domain?
It can equal to.
I hear x cannot equal 2, but everything else. X E double R. X is all of the reals. Make that semicolon a little clearer. That's right. Okay, any questions so far?
We always have to run that. So,
I would. Those are the key features they might quiz you on or test you on. Okay, so the last 2, I look back at the equation. What can you tell me about my powers this time? I look back at the original. Are the degree, is the exponent, the degree the same? Are they bigger on the bottom or bigger on the top? Bigger on the top. Here's the deal. If it's bigger on the top, it's not going to be a horizontal, it's going to be oblique. That means slanted. That's I put a G, that should have been a Q. It's oblique asymptote. That means slanted. We're going to have a slanted asymptote this time. And so to find that value, what I'm going to have to do, it's going to be y equals. It's always y equals for this. For this section, it's always y equals. But here, what I'm going to do is you divide your equations. So if you look back at the cheat sheet, it'll say divide the numerator by the denominator. So I'm going to use synthetic because I can. To use synthetic, you first solve for x in the denominator. What does x actually equal in the denominator? 2. And what I'm going to do is write out my coefficients. I have a 2x squared plus a 4x, so plus 4 minus 30. Whoops, I put 13 minus 30. Leave a space, draw a line. Do you remember who you follow when we do synthetic? You follow your mama. 2 drops. What's 2 times 2? 4. You add these up. I multiply, add, multiply, add. What's 4 plus 4? 8. And you multiply again. 8 times 2 is 16. And we add these and we get -14. Now that part right there is the remainder. This part, if you remember, is called your quotient. Now we started off with 2x squared plus 4x. Do you remember what happens to your power when you do synthetic? It lowers. It becomes 2x plus an 8. That is your equation right here. We're going to have 2x plus 8. That's our oblique asymptote. So let me start adding all this in. I don't know why I haven't done that yet. We have a vertical asymptote at 2.
By the way,
The remainder has nothing to do. That would be the y value. If you plugged in a 2, or if you wanted to find it, but this one's actually undefined there because we're dividing by it. That would be the y value, but it's actually undefined. It won't work. This will have no effect on the asymptote itself. I'll show you a picture in a minute. I'm gonna go really high because I just know what this graph looks like. I'm gonna take this really, really high. But that's x equals 2. That's that value. Now this asymptote means it has a slope of 2 and a y-intercept at 8. 8 is the highest point on this up here. So my asymptote is gonna go, that's 8. It's gonna go up 2 over 1, which is hard to do here. So I'm gonna go down to left 1 is what I'm gonna do. Down to left 1, down to left 1. I'm gonna continue on this pattern all the way across. Down to left 1. Through here. And now I'm gonna extend my asymptote this way, because again, I just know I'm gonna need to see this graph correctly. There's my oblique asymptote. So oblique means slanted. That slanted asymptote is y equals 2x plus 8.
Oh, you don't want to read it. Did you like put that?
Y equals 2x plus 8. No, it's not a fraction. 2x plus 8. I was going, so usually that means up to right 1, rise over run. I couldn't, there's no markings this way, so I went backwards. So it's down to left 1 as well. That would mean the same thing as going up to right 1. Check it out. If I go up 2 and right 1, am I on a point? Up 2, right 1. So you can go down to left 1 as well. So that's what this one looks like. Don't panic on this one. Again, you won't have to graph without a calculator, but I'm just showing you how it works. If I plotted these points, I've done the vertical asymptote, I've done my oblique. I have not done my zeros. I have a 0 at -5. 1, 2, 3, 4, 5. I have a 0 here. And I would have a 0 at +3. Now, since this is only one vertical asymptote, it's only 2 pieces. I now know how my pieces are going to look. Oh, I need to do my y-intercept. I have not done that. Sorry, y-intercept. We plug in 0. When you plug in 0, this cancels, this cancels, this cancels. It's -30 divided by -2. What's -30 divided by -2 going to equal? 15. So it will hit somewhere up here. I don't know where 15 is. It's probably somewhere in this general rate. And so this graph has to come from this asymptote this way, through this point, and it's going to curve like this, hit this, and then it's going to come and follow it this way. This piece comes here, hits this 0, and now it's going to follow this other asymptote way over here. That's what it's going to look like. Now I'll show you on the graph. It's going to take me a second, so I'll pause and graph this here. Okay, so here's our graph. Notice I put everything, I don't know why this says that. That's not the y-intercept. The y-intercept we got was 15. I don't know why it says -7.5. We got that at 15, and that is 15 way up here. This is a 25, so it's counting up to 25. That's 15. We had x-intercepts at 3, -5. Notice, is it following those asymptotes like we suggested it should? Sure is. Now, the next thing we could look at is, according to our domain, where do we say the domain was not going to be, where was this graph not going to exist? Do you remember? Was it only 2? Yeah, and you can see here that that's where the domain does not exist. So we did do it correctly. Now, I know that was kind of a tricky problem, but such is life. I would like to say, hey, we'll do one more before you have a DOL. I don't think we'll have the time. So instead of me doing one more here, we're going to go and I'm going to give you this DOL. Again, I'm taking down the difficulty because truthfully, you'd be tested just on one thing. So your problem's going to be a little bit easier. It should go a little bit quicker for you than some of the ones I've been doing. DOL number 2, find these 6 key features. Let's take a look at irrational factors. Now this one's tricky. I'm not going to lie, this one's going to be tricky. For the sake of space, well, I'll go ahead and show you up at the top for you. You might not want to write this because this is not going to work this time. Let's start here. If we wanted to factor this, do I have a GCF? Answer is no. So I'd say this is A because it's a squared term. This would be B or C. C, it's a constant. So I would do X method, and I would state in the X method that B is actually equal to 0. So I'm looking for factors of -12 that add up to 0. Now, are there integers that I could use to multiply to be -12 that add to be 0? Do I have any? What are the factors of 12? 1 and 12 or 3 and 4, 4 and 3? Do either of those give me 0? This is not rational. What this means, if those don't work, this is not rational, meaning we have irrational factors. Irrational. These are not rational. We cannot do it with normal integers. So we have to use the quadratic formula. I'm going to put it up here, the quadratic formula, and then we'll solve it down below. You're going to use the quadratic formula, and we're going to have to do it for both of these. So here's the formula. X equals negative b plus or minus the square root b squared minus 4ac, all divided by 2a. Do y'all remember doing this on lesson 1.5, I think it was? That's our quadratic formula. We're going to have to use that this time. So let's find the zeros for the numerator. So I'm going to first do the numerator here. I'll just do numerator. I'm going to write that down. Numerator. Numerator. Okay, for my numerator, it's going to be x equals negative b. What's my b value? 0. So it's negative 0 plus or minus square root of 0 squared minus 4 times my a. What's my a? 4 times my c. Negative 3. All this is divided by 2 times a. What's my a? 4. Okay. This I can start simplifying. Negative 0, that just cancels out. The denominator I can see is going to be an 8. It'll be the square root of, what's 0 squared? 0, that goes away. What's negative 4 times positive 4? Negative 16 times negative 3. 6, so it'll become positive. This becomes a positive 48, I hear, and that's correct. Now that can actually simplify again. I'm going to break down that square root. The way to break down square roots, there's a lot of different ways. For now, I'm just going to tell you square root of 48 is the same thing as the square root of 16. I'm choosing 16 because I know that has a good square root times that 3 value. Y'all just did that math in your head. What is the square root of 16? 4. So square root of 48 is the same thing as square root of 16 times square root of 3. You can do that mathematically. So if this is the case, I forgot the plus or minus. I was supposed to have a plus or minus here. And I was supposed to have a plus or minus here. And here now. Okay, 4 can go into 8 how many times? Twice. So it becomes plus or minus square root of 3 over 2. Now here's what's tricky. That's what it is. That's zeros. Quadratic formula solves the zeros. So if that's the zeros, then the factors would become these. Remember, the factors, you cannot have a denominator. How do you get rid of a denominator? Let me actually just rewrite this first. If those are the zeros, the square root of 3 over 2. How do you get rid of your denominator? What's the opposite of dividing? Multiply. It's going to become 2x plus or minus the square root of 3. That means it's going to be 2 separate factors. It's a conjugate pair. Do you remember that term, conjugate pair? We'll have 2 separate factors, 2x plus the square root of 3 and 2x minus the square root of 3. Okay, these are the zeros first. Should have done it this way. These are the zeros. These are the factors. Okay, we did that whole thing. Guess what? We got to do it again. We did it for the numerator. Now when do we need to do it for? The denominator. Let's do this again. X equals negative b. What's our b in the denominator? 4. Negative 4 plus or minus square root 4 squared minus 4 times, what's our a? Times our c. -2, all divided by 2a. What's my a? 4. All right, we go to simplify this. It'll be -4. Whoops. -4 plus or minus. -4 plus or minus square root. Okay, what is 4 squared? 16. This is going to be plus. What's 4 times 4? 16 times 2. 32. So that's 16 plus 32 is 48. All this will be divided by. All this is divided by what number? 8. Well, good news for us. We already simplified that once. So then I go really quick. We're going to have x equals plus or minus. That's going to become 4 goes into 8 how many times? I'm going to write this as 2. I did the plus or minus too quick. Sorry. It should be -1/2 plus or minus. I'm going to make it 2 fractions. And that's going to become the square root of 3 over 2. How do I know that? We already did that one once today. We did it right up here. So now when I want to turn this into factors, again, you multiply it by the denominator. What's my denominator? So it's going to become a 2x, and it won't be a -1/2 anymore. What happens when you move it across the equal sign? Well, what happens to the -1? We've already gotten rid of the 2's. Becomes a +1, and then we have the plus or minus square root of 3 over 2. Those are my 2 factors there. So now I could finally solve the problem. And we're running out of time. So the way it's going to end up is you would just rewrite this equation. I use letter H. And you would write your 2 factors and go from there. The 2 sets of factors. 2x plus the square root of 3. 2x minus the square root of 3. 2x plus 1 square root of 3. 2x plus 1 plus square root of 3. And finally, 2x plus 1 minus square root of 3. Wow. Okay, now that I have this all written out, let's just make note of what everything would become. Since nothing cancels, these factors produce the zeros in the numerator. So these would be our zeros up here. Here and here, these are my zeros. Which means, since I already solved this once, these values right there, those are the zeros of the function. This is my zeros right here. Those are my zeros of the actual function. That's what those actually are. Now, the denominator, since nothing cancels, these would be vertical asymptotes. So both of these would be vertical asymptotes. Now, those were generated right here. Those are my actual equations for my vertical asymptotes. So my vertical asymptotes could be found right there. These would be them. Now the domain is that x could not be any of those values. This would be the domain as well. So I'm going to come over here, just put the domain is that x cannot equal this value here, -1/2 plus or minus the square root of 3 divided by 2. That's what x could not equal. Okay, and I got that from right here, the vertical asymptotes. Let's see, what else are we missing? So we've done, there's no holes, nothing cancels out, no holes. And so what we could do, we could look for the things that are missing here. We haven't done our in behavior. So if you followed your rules, if I want to know, you look at the degree and my exponents, are they big on the top, big on the bottom, or the exponents the same? In this case, the exponents are the same. So I'd have a horizontal asymptote. Since my exponents are the same, I'd use each DC. And it would be 4 divided by 4. So y equals 4 divided by 4, which is simply 1. That's gonna be my horizontal asymptote. Just move that over here. Why not? That's my horizontal asymptote. And finally, my y-intercept. Again, to find your y-intercept, you plug 0 into the equation. So I'm just looking for h of 0 here. And this simplifies, this simplifies, this simplifies. I'm left with -3 divided by -2. Which is equal to +3 divided by +2. So now you could go plot everything on, that would be here. 0, 3/2. That's that point there. We had zeros at these values plus square root of 3 over 2. I think that's approximately 0.8 or so. So positive 0.8 and negative 0.8. Those are going to be zeros all in there. These are my vertical asymptotes, -1/2. And then plus that 0.8. So it's going to be in here somewhere tight. It's going to be in here somewhere tight there. And then -1/2 plus, it's going to be right in between those values, somewhere in there, like that. And we had a horizontal asymptote at 1 comes through this way. So this graph, as you can see, it's going to be an S curve. I can tell by looking at it. It's going to be an S curve right in here. It's the only way to connect all these points. So let me try this again. It's so hard on this little board here. An S curve to connect those points. Going up. I have this 0 here and it has to follow these asymptotes. So this piece has to be going this way. And since it's an S curve, this piece, it must reflect across diagonally. The other C curve is going to be going this way, like this. And so that's how this graph should look. I'll go ahead and put this in and we'll take a look. So control, here we go, 4x squared. Oh, it's not typing. 4x squared minus 3 over 4x squared plus 4x minus 2. And I'm going to go ahead and add those other details in, but you can see so far we're right on. Okay, so I finally graphed it all in. It reduced these fraction or these decimals. That was the square root of 3 over 2. This is negative square root of 3 over 2. You can't really see the negatives there, but that's that other 0. And here's my two asymptotes. This they kept in good form. As you can see, we did do this correctly. That is all of our values there. So I'll go ahead and take that picture of that. So anyways, that's how you do that problem. With that, you have a DOL you can try here. I want you to find the 6 key features using irrational. And then after that, I want you to go on to Google or AP Classroom and try the problems there. You should find 3 to 6 questions for this section.